you can solve in reality ATB plus X equals C. You can solve this one because this is a 2 by 3 times 3 by 2 matrix. And so this is a 2 by 2 matrix. Be careful that you can solve. Oh, now we have another kind of example to get you closer to the argument of the matrix of this part of the course. Consider this equation. Here it's your A, and here it's your xt, and here it's your bt. This is a system. It's a system. It's the following system: x minus y equal first row, first column, x minus y equal 4, and minus x plus y equal 0. As this system, a solution, this system has no solution, as you can tell me. Why? Oh, because if I multiply this, multiply both sides by minus 1, and you obtain x minus y equal 4 and x minus y equals 0. The two equations are contradictory, so impossible, because 4 is different from 0. And all this information that is impossible from now on will be in this matrix. So, and look here. So we have f of x equal a xt equal b. No solutions. So in particular, f is not invertible. It may be the case that a system has solution. A system can have solution without f being invertible. But if the system has no solution, my f is not invertible. This will amount in saying that the matrix is not invertible. We will see what invertible for a matrix means. It will be invertible with respect to multiplication by another matrix. So from now on into the class, we will restrict our attention to square matrices. Matrices having the same number of rows and the same number of columns. Naples by Naples. Padua by Padua, all this kind of matrices. And these linear matrices correspond to linear function from spaces of the same dimension. Let's classify somehow in a relevant for us way matrices. We call a matrix a square matrix symmetric if it's equal to its transpose. Oh, what does it mean? It means that somehow the matrix is symmetric with respect to the diagonal. You can swap what's above the diagonal and what's below the diagonal, and you obtain the same matrix. A diagonal matrix is a matrix that such that for all entry outside the diagonal, you have them zero. A triangular matrix is a matrix that has all entries above or below the diagonal equal to zero. What is the diagonal of a matrix? Let me, given A, the diagonal of A is AII for all I equal 1 to n square matrix. So let's see how a diagonal matrix appears. Diagonal matrix. You have A1, A2, A3, AN, and below 0, 0, 0, 0, everywhere else 0. And triangular matrix. A triangular matrix, for example, is here we have A1, 1, A, I, A, N, and below the diagonal, everything is 0, and then you have A21, A1N, A1N, A12, A2N, and here you have, is this an upper or a lower diagonal matrix? So let's have the definition. An upper